Boom! Yes folks, Hume again. So we're continuing with our series of videos on trigonometry. Alright, in this video we're going to continue what we did in the last video, where we're talking about special right angle triangles with a view to illustrating the trigonometric ratios for the purpose of having people understand it clearer. So in the last video we would have done the 30, 60, 90 triangle. So in this video we have the 45, 45, 90. Of course you have a 90 here. This here is what makes the triangle a right angle triangle. You have 45, 45, 90. So just as we did with the last triangle, this is the 45, 45, 90 triangle, or we could call it a 1, 1, 2 triangle. Again, this refers to the ratio of the angles, not the ratio of the length of the sides. Good, keep that in mind. So with this angle, with this triangle now, we could get into another trigonometric ratio that is fundamental, right, to your whole experience of trigonometry, and that is the ratio for the tangent of 45, because we know that the tan of 45 degrees is just equal to 1. Why is it equal to 1? Because the length of this side is equal to the length of that side. So anytime you have a right angle triangle where one reference angle is 45 degrees, let me call it theta, then you know immediately that phi, which is the other angle, must be 45, because after all, theta plus phi is equal to 90 degrees. Good. So this, if you recognize, is an isosceles triangle, because you have two angles here being equal. If we make this the base and these are the other two sides, and by virtue of these two angles being equal, it means that these two sides here will also be equal. Good. And that is what makes the tangent of 45 1. So in other words, if your reference angle is here, then this here is the opposite side and this here is the adjacent. So opposite over adjacent, 1 over 1 is equal to 1. So in other words, all it means is that once the reference angle is 45 degrees in a right angle triangle, the length of the opposite side is equal to the length of the adjacent side. So if this side is 23 meters, then this side is 23 meters. If this side is 65 kilometers, this side is 65 kilometers. If this is 286.95, this would also be 286.95. So when we talk about that ratio of 1, all it means is that, let me make the connection here. All we mean is that this will be opposite over hypotenuse. Alright? In this case, that would be BC over AB, which is equal to 1 over 1, which is equal to 1. And the only way that this here will be true is if BC is equal to AB. And if that is the case, then what will happen when we come across here now? You'll get the same thing, right? You'll get that the tangent of 45 degrees is equal to, watch it again, if your reference angle is here, let me call this phi, then this here will be opposite side and this here will be adjacent, right? Opposite over adjacent. So your tan 45 will be opposite over adjacent, which is equal to, in this case it would be AB over BC, which is still 1 over 1. And because AB is equal to BC, whatever the lengths are, in this case we're just using 1 for simplicity, but it could be anything as long as BC is equal to AB, which means then that the final ratio would actually be equal to 1. Good. So of course, if you know that the tan of 45 is 1, it means that this side is 1 and this side is 1. It means then that we now could employ Pythagoras Theorem to find the length of AC, which is the hypotenuse in this case. All right. Remember, of course, the hypotenuse is always the side opposite the right angle. So I am going to, what should I do? Alright, I'm going to rub this off. So we're using Pythagoras Theorem, and we're saying that, again, this is hypotenuse, right? So by Pythagoras Theorem, h squared is equal to opposite squared plus adjacent squared. Whichever 45-degree angle you choose to use wouldn't matter, because in this case, because these two sides are equal, it means that 1 squared plus 1 squared is equal to h squared. So that h squared is equal to 1 plus 1 is equal to 2. So therefore, if h squared is equal to 2, then h is equal to the square root of 2, which is equal to 1.41 to 3 significant figures. Good? 1.41 something something something. So I need a little space up here. This is 1, bring it a little closer. Good? And then we come here now and we make this be equal to, what color we use? Let me use a different color. Let me use the color, let me use the same black. No, let me use the green. Last time we used orange. So in this case, your hypotenuse is 1.41. Again, I am deferring to the majority of math students who will not necessarily be doing odd maths by using the decimal form of root 2 as 1.41. Of course, odd math students, this is the third form, and in the case of odd maths, you'll be using that form more often than the decimal form. Alright, and of course I will take this opportunity again to let you all know that yes, we have some nice stuff coming up in the odd maths where this preparation for January 2021 is concerned. But more on that later. So that is basically it. That is basically it, right? So if there's one thing that I could give at the end of this video, if you want to understand the concept of the trigonometric ratio, there are 2 ratios you need to understand. One is that sine of 30 is equal to a half, right? That's the first one. And tan 45 is equal to 1. With those 2, you could do a whole set of things. Because once you understand that the sine of 30 is a half, then you're in a position now to derive the cosine of 60, which is the same half, right? But I wouldn't talk about that now. I will deal with that in a separate context, maybe with the odd math students. Good? If you know that the tangent of 45 is 1, then you could derive, for example, now that we have the length of the hypotenuse, and I'm going to rub off here, you could derive that, let me start with the sine. You could derive that the sine of 45, good, the sine of 45, sine 45, let me go with this 45 here, is equal to opposite over hypotenuse, right? And 45 is equal to opposite over hypotenuse, which should be equal to 1 over 1.41. 1 over root 2 is how much again, boy? 1 divided by root 2 is equal to 0.707. Yes. So to 3 significant figures, it will be 0.707. And if we try to find the cosine of 45, let me use this same 45. Alright, so in fact no. Let me use the green 45. In fact no, let me use this 45. Cosine of 45 adjacent over hypotenuse, the same one over the same 1.41. So the cosine of 45 is equal to the adjacent over hypotenuse, which is equal to 1 over 1.41, which is the same 0.707. So in other words, the sine of 45 is equal to the cosine of 45. Alright? So some basic ratios that if you have these in your head, you could start and you could do almost anything at this level, right? You start off by saying that I'll start off with where my starting point is in my head. In my head, the starting point is sine 30 is equal to a half. Now, the starting point might be different in your head. That is perfectly fine. Nothing is wrong with that. So, in my head, I would say sine 30 is equal to a half, which means that when I put down the triangle, right, 30, 1 over 2, I use Pythagoras Theorem and I get this here as the square root of 3. Good. And if sine of 30 is a half, then we know then that the cosine of 60 is also equal to a half, because this being 30 means that this here will be 60. Let me draw a nice big triangle now. Right? 30, right? 60. So sine of 30, opposite of hypotenuse. When we switch the reference angle to 60, cosine of 60, adjacent over hypotenuse, same a half. Good? So there will be the same sides, it's just that the name of the side would be different because of a difference in the reference angle. And by the same token, we could say, too, using this triangle, that the tangent of 45 is equal to 1. And what that will lead us to is to realize that the sine of 45 is equal to the cosine of 45. We will leave out the actual value for now, because for the purposes of simplicity, I just want to stick with integers here. Right? Sine 30 is equal to a half, which is the same thing as cosine 60 is equal to a half, which is the same thing as tan 45 is equal to 1, which is the same thing as, well, this will lead you to this. Sine 45 is equal to cosine 45, because they have the two angles there being equal. So that is it as far as the preliminary basic explanation of the trigonometry is concerned. What I want to do is take this opportunity, having come to the end of this series on trigonometry, to talk to the people who are still here. Right? If you're still here and you're at this point in this video in my series, then it means that one of a few things would have happened. One, you would have looked at a video and assumed, of course, that you would have been engaged right through in terms of following. It means that you understand what I was saying, and you could then take that understanding and apply it on your own. So in other words, you wouldn't need my help and you wouldn't need anybody else's help. Perfectly fine with that. That is not a problem, right? Because at the end of the day, there will always be people who don't necessarily need your services, right? But at the same time, you're putting out the information because it could help somebody, and that's the whole idea. It could mean also that you understand the thing, but you have somebody else helping you. That too is perfectly fine. Nothing is wrong with that. If you have help already and you go with them, right? It could mean that you need the help and you wouldn't mind coming by me. Now, if you come by me, there's a lot more in the online setup that I have put up, right? Apart from these explanations, which you will get, we will be doing examples. You have questions, you have answers to the questions, you have the opportunity to interact with whoever else you're interacting with, you have the opportunity to interact with me. We'll be doing examples, possible questions, hard questions, etc., etc. So in other words, for the next level of learning now, which is the critical level, the level where you're doing, the level where you're making mistakes, the level where you're learning and you're growing, and there is a different level, right? Watching the video and understanding it is one thing, but doing the questions is a different thing. Is, as I would have mentioned in a video some time ago, it's like learning to play a musical instrument. It doesn't matter how much YouTube videos you watch. It doesn't matter how much books you read. It doesn't matter how much music you listen to. At some point, you have to pick up the instrument and play. Right? There'll be times when it's sounding too good. There'll be times when you're off key. Blah, 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 blah. But the whole point is that you have to play to learn. Mathematics is the same thing. This is not a reading subject. So I want to encourage you all strongly. If you understand what we see in the video, great. But greater still would be for you to do the work. Get it done. Do the practice. You have to put some time to it. Alright? And that is why so far I have been resisting appeals from various quarters to shorten the length of the video. This is 7 minutes, 5 minutes, right? People giving different times. But at the end of the day, this thing is not entertainment. At some point, you will have to learn to sit down in one place for more than 5 minutes. If you can't do that, then forget about maths. Forget about maths, right? And the ability to sit still for a period of time, that is one of the most important skills you could ever develop in life. Whatever you're doing, it doesn't matter what you're doing. At some point, a certain degree of stillness would be required, right? We have a generation now where to sit down still and to be quiet is a sin, right? No, 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 no. So as I tell people all the time, teaching the maths is the easy part. Getting inside people's head, that is the hard part. Alright? So if you're ready for that challenge and you're up for that challenge, come with me and let me do the thing. Alright? So, thanks again and keep in touch. We have plenty more coming your way. Yo!